Welcome back, everyone. We are now in our third session of our event today, which is the second keynote speech entitled Reimagining Plantation. For this keynote speech, we are proud to have Dr. Harikrishna Kulaveerasingam as our speaker to share his point of view in plantation. Before we proceed, allow me to highlight a few gentle reminders. Firstly, please make sure your microphones remain muted throughout the whole session to avoid any interruption. Secondly, we will be having a short Q&A session later right after the speech, and we will be using Mentimeter for our Q&A session. Hence, if you have any questions, kindly type your questions in the Mentimeter and I will bring out your questions later. The Menti code will be sent together with the Menti link later in the chat box. And lastly, we'll have a photography session at the end of this talk together with our speaker. Hence, everyone is highly encouraged to turn on your cameras during our photography session later. Now, without wasting any time, allow me to introduce our honorable speaker of this session to the floor, Dr. Harikrishna Kulaveerasingam. For your information, Dr. Harikrishna is currently a Chief Research and Development Officer. He obtained his first Bachelor of Science in Plant Sciences from the University of London, Wye College, before receiving his PhD in Plant Developmental and Molecular Biology at the University of Leicester, United Kingdom. He started his early career in Malaysia at Golden Hope Plantations and having more than 30 years of postgraduate experience in biotechnology. He had an academic career at University Putra Malaysia. He is also a fellow of the Malaysian Academy of Science. Without further ado, let us welcome Dr. Harikrishna to the floor to present his speech. Please.
Hi, good morning, everybody. Let me share my screen. Thank you very much for inviting me to actually share some of my thoughts with all of you. A very good morning to all of you. So title is Reimagining Plantations, right? And many of you most probably have certain preconceived notions of what a plantation would be, and most probably you won't be all that far wrong. It is always seen, work in the plantation is seen to be the 3Ds, dirty, dangerous, and demeaning, right? But I'm hoping that by my presentation today, you'll see that things are changing in the plantations, and we are very much moving into, let's say, this century towards plantation 4.0, let's say, right? So without further ado, let me close this so I can actually see my slides. So without any further ado, let me just talk to you about essentially what are the challenges the oil palm industry faces, right? So all of you are aware of all the sustainability related issues, right? For example, it is now not possible to expand our land area because of commitments made to not clear forests and to not plant on peat. So that means that any there's very limited available land. Also, any expansion or even current operations really needs to take into account the reduction of greenhouse gases emissions and any other carbon and water mitigation measures, meaning to say we need to reduce our carbon footprint as well as our water footprint. We need to do that whilst preserving the health of the soil, keeping the soil fertility in place. And if we're able to do so, then we'll be able to support good growth of oil palm, right? But on the other side, the productivity and cost side, We have problems with particular diseases in terms a root-borne disease called Ganoderma, which at the moment there's no cure. We have opportunity for superior planting materials. We need to deal with climate changes, and therefore these materials need to become climate resilient. All of you are aware of all the labor issues. The oil palm industry is very labor dependent, and therefore that the inability to obtain labor has really dramatically impacted the industry. So we need to actually upskill our labor and reduce the amount of labor that we use. And we need to do all of this whilst basically achieving improved yields so that our productivity improves and our cost of production comes down. So, let's move over. Okay, in order to do this, innovation is essential, right? And Sime Darby has been involved in this journey or this innovation journey for many years, since 1985, when we first introduced the zero burning technology, to today, right? And I guess the notable achievements would be, from a scientific standpoint, would be our genome program, which in 2009, we essentially completed the genome sequencing, the genome select planting in 2016. And then digitization, which is actually still a journey that we are undergoing. And then all the various platforms for engagement with our customers, right? And providing transparency in the supply chain to our customers. And we have built up an innovation infrastructure that is managed or is chaired by our group managing director. And so we have the highest authority in the company actually looking at all these innovative concepts and projects. And he will approve the funding for these programs. We've created an open innovation portal where we work with many different entities. And we also engage with various entities, universities, corporates, and others, right? To actually provide innovation challenges out there and to try to move this forward, right? So if we look at sustainable oil palm growth, we need to increase productivity essentially in two areas. Firstly, yield potential. So in our research program, we've gone from the lab to the field in 7 years from our genome program, right? So from 2009 of getting the genome information, we are able to convert it into something that is, let's say, the technology is then embedded in the seeds, and we planted that in 2016. But it's not good enough to actually have good seeds or high-yielding materials. We really need to deliver realized yield, and that realized yield must be of high quality. And the only way to do so is to actually get the bunches processed as soon as possible so that they're fresh and you get high quality oil going to our refineries. And in doing so, we actually deliver and support the customer's expectations. So realizing yield across large hectareages is not an easy task. So the journey, of course, starts with pure seeds with the highest yield potential. And this is where our Genome Select platform essentially comes good, right? So let me share with you essentially what oil palm breeding is all about, or seed production is all about, because I was told that most of you are engineers. So the commercial palms that are planted are hybrid called the Tenera, right? Which is, let's see, which is down here, right? Okay. And it is produced from crossing a dura, which is basically a thick-shelled fruit. This is the shell here, right? With a variety of oil palm, which is shellless, called the Piscifera, right? So the Piscifera is always the pollen donor or the male parent, and the dura is always the female parent. And the reason being so is because the piscifers are, in most cases, female sterile, even though you got a fruit here, but that fruit is it doesn't produce many bunches, right? And in most cases, it hardly produces any bunches at all. So when we cross these two, we get an intermediate, meaning to say we have a lot of mesocarp, as you can see in this fruit at the bottom here, right? And you get a thin shell and a fairly large kernel, right? So you get the best of both worlds, really. And this basically allows us to maximize oil yield. However, in terms of breeding, because the dura can be, you can look at dura performance by weighing the bunches and so on and so forth. So that's okay. But piscifers, the only way in which you can tell the piscifera is performing well is through the tenera. And therefore, this makes the breeding program extremely long and cumbersome. And therefore, actually having access to markers that can expedite this can make a huge difference. So we've developed through our genome program actually virtual breeding platform where we can simulate thousands of crosses and then identify which are the best parents to combine in real life, and then deliver improved materials as a result of that. So as I mentioned earlier, this journey started actually before 2009, but 2009 we completed the sequencing, and since then we had to make sense of all this genomic information. And at Sime Darby Plantation, we're very lucky that we've been involved in breeding of crops, rubber and oil palm, for about 80 years. So we've leveraged on all these populations of materials that we've collected and utilize this genomic platform to actually provide us insights. And what it's allowed us to do is to develop, let's say, improved materials, as I said, through this new digital breeding platform that we developed. It's also allowed us to develop other tools that ensure that the quality of the products that we produce are of the highest standard. We've also produced IPs, that unique IPs, and also shared publications with the rest of the industry to try and help support development of the industry in this space. So as I mentioned earlier, the whole idea is to actually utilize the information or the knowledge of the genetics of these populations of oil palms that we have collected over the past 80 years, make sense of it, try and understand the genetics and the traits that they contain, and actually then move it forward to produce the best quality seeds. So we've successfully, if you look at the Genome Select and the Calyx 600, Calyx 600 is the material that is what we sell at the moment. And the Genome Select is actually is the new material that we are planting today, but it's not available for commercial sale yet. If you look at the images there, I hope that you are able to discern that the shell of the Genome Select is thinner and the mesocarp is a bit bigger, and therefore we deliver about 15% additional oil. So we went about the journey of commercializing this technology. And the first thing that we did, besides actually producing these better materials, is to ensure that we had the tools developed to produce the highest quality seeds. So we have genetic tests that allow us to actually take samples at random and to ensure or to verify their purity. So we have materials called the Calyx Q6, where we guarantee over 99% purity, right? So this means that they are the correct cross. And a 0.1% decrease in purity for a company like Sime Darby Plantation is equivalent to about 1 million ringgit loss per year. Then we've developed tools, as I mentioned earlier, to optimize our breeding. So we have a virtual breeding population where we can test predictions of different background materials and then make the best parental combinations. Now, in order to do this without this technology would have taken us many, many years and a lot of land. So this helps us to maximize productivity from a breeding perspective, because you reduce the amount of land area for trials, and you're able to actually, let's say, virtually test many different combinations that would not be possible to do in real life. We also then use this platform as a means to advance, let's say, introgression of new traits. So we have these advanced materials that produce high yields, but sometimes useful traits are found in the wild populations or wilder populations, let's say, like, for example, short height increment, drought tolerance, disease resistance or disease tolerance. So these need to be incorporated into the high yielding backgrounds. And when you use this genomic platform technology, we're able to do what we call these introgressions, right? Much faster. So that's basically on the genomics platform. But let me switch gears now and talk about digitization. So all of you are aware that digital technology has really moved along very quickly, and all industries are actually looking to digitization to improve their productivity and efficiency. We are no different, and we're leveraging on this platform to actually improve our efficiency and also improve our capability of delivering high quality products to our customers. So from precision farming to connecting our mills and refineries to actually providing, let's say, advanced knowledge to our marketing team so they can make the informed decisions for selling or purchasing of oil, integrating our value chain. So that means to say connecting all the information from all the various operations within Sime Darby Plantation, and eventually ending up with what we call, or what we term as an intelligent enterprise, meaning to say we then can do predictive, we can do then data analytics and provide, let's say, more in-depth information, as well as provide predictive information to the operation so that they can make the best decisions. So one of the, as an example of actually utilizing this kind of platform, we decided to build a platform that allowed us to fully trace our seeds. So it's important for our customers who purchase Sime Darby seeds to know or to verify that their seeds came from specific crosses. So we built this platform. So all of our pollinators, and you can see from the left here, this is the pollinator. So all our pollinators are given a Samsung smartphone, and then there's a RFID tag on the mother palm that is scanned to verify that this is the palm that this is the Dura palm that they're going to use for the cross. Then he's given essentially pollen in tubes that are barcoded, and he needs to scan the barcode. So then the system captures that data in the cloud, and that the relevant cross is going to be made. Then after the cross is made and this inflorescence is bagged, there's a chip that is actually inserted in there to ensure that once this is done, once the pollination is done and the bunch forms, that chip remains with that bunch all the way to the factory. And then finally, you have a product that is marked specifically with the pollination date and so on and so forth, right? And you can see this is what it looks like on the screen for the workers, right? And then we independently test. We take some samples of seeds from these bunches at random, and then they are tested, they're subjected to a DNA test to ensure that they are pure, right? And this is to ensure that that whole process has integrity, right? And so in doing so, we provide our customers a fully traceable platform for the product that we sell them. So, as I mentioned earlier, the most difficult element of our operations is actually to realize or to capture the yield, right? From a commercial standpoint. So whilst we produce now good quality seeds, we still need to ensure that that yield is actually can be captured and can be processed, right? Whilst reducing reliance on our labor. So in order to do so, we have actually leveraged on precision agriculture as well as mechanization as a means or as a platform to push this in the right direction, right? So so precision agriculture allows you to make or to provide precise planning by using weather data, satellite imaging, and so on and so forth. You're able to precisely apply the inputs, be it fertilizers, be it pesticides or whatever, at the right place at the right time. And you're able then to use the data to provide some form of analytics and some form of predictive capabilities, right? So therefore, you provide the right solution at the right period of time. And despite the potential, let's say, for improving productivity and reducing costs and so on and so forth by deploying precision agriculture, less than 20% of agricultural land is actually managed using these digital technologies, right? And most of it is actually in Europe and the United States. So we've developed, or we've tried to develop a management system, right, to deploy this precision agriculture. We call it the SMART platform. And we've come up with a dashboard. So in this image on the left here, you can see that there's a number, the temperature, then wind speed, then vapor pressure, rainfall, and so on and so forth is captured, right? So this provides the management with the useful information. So the precision agriculture unit that we have at IChemE-Universiti Plantation actually has developed the capability of using remote sensing through either satellite imaging or drone imaging to provide geolocation services, right? And it's delivered in a particular platform that is a visual platform, right? So all of this actually then translates into, let's say, output that the plantation operations requires. For example, palm count, the palm health index, we call it a vitality index, and then various operational dashboards, right? We also do, we can also virtualize, let's say, water management, meaning to say we can predict which areas would flood depending on what level of rainfall that is deposited in those areas, and then what kind of improvements to the drainage that need to be made, right? So you can do all these various types of assessments. So it's a very powerful platform. So the most important thing is at IChemE-Universiti Plantation, we most probably have about 80 million trees or palms, right? And just like human beings, we are all unique. So each one of these palms are unique. And the whole idea is actually to be able to provide the right inputs for those individual palms, right? So to treat them as individuals. Currently, we manage these palms on the basis of either 20 to 50 hectare blocks, right? And that's clearly not good enough. But if we are able to actually then identify what each individual palm requires in terms of nutrients or in terms of pest and disease management. Therefore, they will be much more productive. So firstly is knowing our palms. Secondly is helping them grow. So to provide, let's say, inputs. So in this image here in the center, you can see these red areas and the green areas. So the green areas are healthy. The red area is unhealthy for whatever reason. And in this case, it's because of flooding, right? So when you have these kind of images, then it's very easy for the operations to identify where they need to go because they're GPS coordinates, what they need to do because they can do this virtual assessment of, let's say, improving drainage and so on and so forth, so that the work can be very efficiently expedited. And then on the far right here, protecting our palms. So we have this tool which allows us to identify palms that are afflicted by Ganoderma and do it fairly effectively, more effective than humans. And then after that, we can respond accordingly, right? So as I mentioned earlier, oil palm is highly labor intensive, and producing high yield is not good enough. It's wasted if we cannot get the crop to the mill as fast as possible. As I mentioned earlier, we need to have fresh crop taken to the mill that can be processed immediately, and therefore we produce a high quality product. The recovered yield is what counts, right? And as I mentioned earlier, crop freshness is what drives quality all the way to the products on the shelf. And if it is a good quality product, then, for example, for frying, it has a longer frying life, and also can be used for baby or infant formulations, right? Without any issues. So if you think about labor in the estates, it can be divided into three components, or I call it here 3 buckets, right? So firstly is harvesting. Harvesting is highly skilled, and essentially this is the main rate limiting step, okay? And it's also most critical because it's skilled, and therefore we can't get enough workers to actually do this job. So this is the holy grail of mechanization. It's extremely difficult to design a machine that can harvest efficiently and effectively. You can design machines that harvest, but not efficiently and effectively, right? So at the moment, there are no satisfactory alternatives, right, to harvesting, even though we are all working on various solutions, right? A lot of it is down to the architecture of the palm. The next bucket is crop recovery. That means to say collecting, transporting bunches, as well as the fruitlets. So you have loose fruits that need to be collected as well. This is the most labor intensive. It's also terrain dependent, and it's time critical, as I mentioned earlier, that this should be collected and sent to the mill as soon as possible. So we have machines that do this job. And finally, field upkeep. So fertilizer, pest and disease, nursery management, and so on and so forth, right? And keeping the fields clear of woody growth and so on and so forth. So this is the one that has the lower priority, should I say, especially at times like this when we don't have labor, but there's a long-term impact of neglect on yield that can be significant, right? And it's dynamic, it requires many different tasks. So let me just talk to you a bit about the collection of bunches and loose fruit and transportation to the mills, right? What kind of machinery have we developed? I just give you a few examples, right? So this is what we call a mini MBG or mini badang, right? Mini badang, right? And it takes up to about 600 kilos in weight. And the productivity is up to 18 hectares per day. It can cover about 18 hectares per day if there is a skilled person operating it. It has a scissor lift that can lift up 2 meters so that you can dump the crop into a 10-ton bin. It is a relatively small machine, which means that it can actually operate in confined space. It's relatively light as well, and simple, and therefore in most cases it would not get bogged down under plantation conditions. So unlike a tractor that is fairly large, can get bogged down in the field, this machine most probably would be able to move through the field without causing too much damage. So let me share with you a machine that we are in the process of developing. Is not fully there yet, but it's getting there. And this is done in collaboration with University Putra Malaysia. And the whole idea is to develop a platform that even a housewife can operate, right? It should not be laborious. It should be relatively simple to operate, and they should get high productivity out of it so that their wages can be also significant, I guess, right? Okay. So currently it takes about 30 seconds per bunch, and we need to get it down to about 20 seconds. So we're working on improving this. You can see this is a hydraulic, but the operator is not touching any of those hydraulic controls. There are camera systems on this machine that identifies where the bunch is, and then there's a AI developed to operate that arm to pick that bunch and deposit it into the carriage at the back. So as I mentioned earlier, it's not a finished product yet. There's still some work that needs to be done, and the movement of the arm can be improved. So this is what we're working on at the moment. Okay, so we call it automated grabber system, right? Okay, next thing that, so I mean, that is just one of the machines. There are many other machines that we're developing. So how about field upkeep and nursery management? So for oil palm, fertilizer application, pest and disease applications, and seedling management is very important. So for pest and disease, we use drones, and for point-to-point spraying and so on and so forth. But I don't have any slides in this deck. But I think many of you have seen it on YouTube and so on and so forth. So I consider that to be a job done. But fertilizer application is still for flat areas. There are machinery that work, but in, let's say, undulating areas or terrace areas, it's still an issue because these large machines can't move in. So I have another video here to share with you. This is most probably how you imagine the plantations to operate, right? So this is the earlier version of our machine, and this is the new machine. The operator has two buttons there, and he would press the button to dispense a specific amount of fertilizer at a specific site. And we are working to actually introduce an AI to make this more automated, right? Okay, I'd like to finish off on talking a bit about the milling and refining, which I think all of you are engineers, so you most probably be more interested in this. So we are moving towards a unified control center. Currently, we are somewhere between Industry 2.0 and Industry 3.0, meaning to say we have a sort of automation pyramid. We have SCADA systems and so on and so forth that allow us to collect data and various sensors, right? And but it's acted upon in a manual manner. So we are transitioning now to Industry 4.0 type platform, which is a lot more automated, that has feedback loops and so on and so forth, so that once this data is collected, is processed and acted upon immediately by switches within the equipment, right? So that there's no lag time for somebody to walk over and use a spanner to change the setting on a particular operation. So talking about basically integrating mills and refineries. So we're talking about industrial automation. So we want to create smart factories, which are all fully connected, right? And then these smart factories allow us to be more proactive and then eventually predictive, where we can do all the predictive maintenance and so on and so forth. So this is a real image of our R&D mill. So it is fully connected. It has 200 sensors, and essentially we have software to control everything in the mill. So the idea then is to actually start to roll this out into the operations, right? And then also to have IoT in agriculture, meaning to say connect up the operations, the upstream operations with the mills and then with the refineries. So this is the ultimate goal of what we are trying to put in place, right? So that we have a so-called unified control center that connects all of the dots. And it's a very large undertaking. So this is how we see it holistically, meaning to say in operations, you'll have those machines, as I mentioned earlier, they are GPS enabled and so on and so forth, so that you are able to tell where it is. You will have, let's say, low emissions vehicles, whether they're hydrogen powered or whether they're EVs or whether they're fueled by biodiesel. That is to be debated, but ultimately there should be zero emission machines that then take these crop to the mill, where the mill is actually super efficient. It has basically all the command and control centers with automation and sensors, allowing it to be extremely efficient, right? And after that, even the power generation, all the CO2 that is produced is then basically recycled back via algae farming and so on and so forth, so that it has a very small carbon footprint. And by using various technologies for effluent treatment, we also end up being zero discharge. That means to say have a very small water footprint, whereby the treated water can be used as boiler water. So this is the ultimate of what we are progressing towards, and the various colors are essentially stating where we're at in terms of our R&D program, right? So some of it's already ready, deployable. So as a conclusion, right? So the way forward, what are the learnings? So one of the learnings is that whenever we do POC trials, proof of concept trials, right, it needs to be done under commercial conditions. And under commercial conditions, then we are able to demonstrate the effectiveness and the value of whichever technology platform that we are talking about, the return on investment, the expected productivity improvement, labor savings, and so on and so forth. Then, we will be able to get, let's say, support from our management to actually fund all of this to be done and rolled out. So the kind of things that we're looking at immediately in the short term is easily implementable solutions. For example, drone spraying, I mentioned earlier, precision agriculture tools that we've developed and started to roll out. And then where possible to reduce and eliminate manual operations, right? And encourage localization of the workforce. So as we develop machines that require lower skills or lower, let's say, strength input and so on and so forth, we can then encourage more locals to get into the workforce without a reduction in the productivity, perhaps an increase in productivity. So on the medium term is to target the development and deployment of these semi-autonomous machines and processes that are easy to operate with high productivity and essentially low labor input requirements, right? And in the long term, to develop and deploy fully autonomous mechanized solutions for all plantation operations, including harvesting. And therefore, we will have full Plantation 4.0 deployment. So that is the ultimate aim. So timelines, immediate is within 2 years. Medium term is 2 to 5 years. And the long term is most probably post 5 years. So data is the new currency and data analytics is the new bank. So with all this digitization, we are collecting data, and that data is key to being efficient and effective. With that, thank you very much.
Thank you, Dr. Harikrishna, for the insightful presentation. Now, before we move on to our Q&A session, we would like to welcome our very special guest, Yang Berbahagia Tan Sri Emeritus Professor Datuk Dr. Agustin Ong, for joining us today. Thank you, Tan Sri, for sparing your precious time with us today. Now, let us proceed with a short Q&A session. Dear participants, for your reminder, if you have any questions that you would like to ask the speaker, kindly proceed to www.menti.com and key in the code 3850-4439 to post your questions, or you may click the link provided in the chat box. I will direct your questions to our speaker. Dear Dr. Harikrishna, please be patient while we are collecting the questions from the participants.
Sure.
Okay, let's see. So the first question is, can we see the benefits of mechanism in your company or industry very, very soon? Can this be a solution to global food crisis? What do you think, Dr. Harikrishna?
Yes, we can already see the benefits of mechanization. As I mentioned earlier, the drone spraying has reduced a lot of labor requirement already today, right? So we use drones to spray our nurseries. We use drones for the first 2 years of our oil palm plantings, and we spray every 2 weeks. So it's very effective. And as I mentioned earlier, reduces labor greatly, right? Now, is this a solution to the global food crisis? I don't think so, because global food crisis is not just palm oil, right? It's all kinds of other crop plants as well, right? It's grains and so on and so forth. But it does, let's say, take a positive step towards addressing it, right? At Sime Darby Plantation, we've also introduced, as soon as we develop machines, we roll them out as soon as possible. So we have actually implemented many different machines to our operations, and there has been a decline in the labor requirement. I hope that answers the question.
Yes, I think you answered the question. Thank you, Dr. Harikrishna. So let's move on to the next question. The question is, palm oil industry gives uncertainties on its global market, and students find it unattractive. What's your view on this?
I don't understand what the question is about in terms of uncertainties on its global market. I assume what you mean is that the commodity price fluctuates, and therefore certain years we are, let's say, not that profitable, and other years at the moment we are very profitable. So I think at the end of the day, innovation is what we require. So we need to add value to the product. We cannot just be producing a low value commodity product. It has to be a higher value product that the customer is willing to pay extra money for. So the question is, how do we do that? And what kind of products fit into the market requirements of our customers? So that requires innovation. That requires good thinking and product development, right? So I think all of the industry members are all cracking their heads how to actually move their profits or their products in this direction, right? So I think it's just a matter of time that you start seeing a whole load of new, let's say, products that add value to the industry.
Thank you, Dr. Harikrishna. Moving on to the next question. Question is, do you see mechanization development more important than net zero commitment? Does both development independent of each other?
No, I think basically everything needs to be looked at holistically. So everything that we do, we look at it holistically. So mechanization is part of the journey to improve efficiency and effectiveness, right? And if you are able then to be more efficient, you reduce the net carbon emissions, right? So that means to say per ton of product, if you're able to actually produce that product, let's say you get higher yields, you reduce the amount of emission per ton of that product, right? So I see they both are complementary to each other and they both are supportive of each other. And we always take into account what is the impact on our carbon emissions.
Okay, thank you, Dr. Harikrishna. So for the next question, the question is, smallholders may find it difficult to commit to IR 4.0 or mechanization. Does big plantation company help them so the overall industrious image can be leveled up?
So definitely, I mean, not many companies can afford to have R&D investment like what Sime Darby has, right? We have over 150 scientists working for us, right? So, I mean, that's a big commitment. But I think, like, for example, all the machines that we design, we don't manufacture it, right? We IP it and we license that IP to essentially small engineering companies to manufacture. And they pay a small licensing fee to us. So all those machines are actually available to the rest of the industry and also to smallholders. So perhaps smallholders need to look at essentially forming cooperatives so that they can afford the machines. Because obviously, if you have 5 hectares or 10 hectares, it's not worth your while buying a machine, right? But if you are able to share that machine with, several other people, then there is economies of scale there. There's also an opportunity for some of you guys to become entrepreneurs and provide services to the smallholders, right? Like what has happened in the paddy industry, right? Where most of the machinery is actually provided by third parties, not by the actual farmers themselves, right? So how does a big company help to level them up? Well, we try and engage with them and try and support them by amalgamating all the crop that they produce and try and encourage them to produce that crop in let's say a more sustainable manner, right? And as I said earlier, all the platforms that we develop are licensed out and available to the smallholders to purchase.
Thank you for your insightful answer. So for the next question, the question is, what is the biggest hurdle for the mechanization in the palm oil industry, especially in the estate?
Well, it's harvesting. Harvesting is the most difficult operation to mechanize or robotize, right? So, and a lot of it is down to the architecture of the palm. And, each breeding cycle takes more than 10 years. So one breeding cycle is 10 years. If you compare that with rice or corn or whatever, It's all done in 4 months. So every year, if the weather is permissive, you can at least have 2 cycles, right, of crossing. For oil palm, we have to wait 10 years per cross before we get all the data and whatever else to know which one is good or not. So if you want to change the architecture, say, for example, I postdoc in UC Davis, which is the tomato capital of the world. Their tomatoes that they grow, the fruits are all at the top of the plant. So they use a combine harvester to go through and shave the top of the plants, right? And that basically gets most of the tomatoes harvested. And, they have to have a breeding program to change the architecture of the plant so that the fruits are at the top of the plant. And it's doable for tomatoes. But for oil palm, if you want to modify the shape of oil palm, it will take many, many years, right? So then we have to adapt the machine to the shape of the oil palm at the moment, which is the biggest challenge, right? Because it produces fruits throughout the year. The fruits are lined around the crown in 360 degrees, right? So any machine must be able to access or assess those various parts of the canopy as well. And then you have the fronds in the way, right? So it's a big challenge. And then these palms also grow. They don't stay at the same height. So the machine must be adaptable, and yeah, it's challenging. Yeah.
Thank you, Dr. Harikrishna. So due to the time constraint, we shall proceed to the last question, which is, do you think in overall, universities have given the right attention to develop talents for 4IR and for palm oil sector?
I can't speak for the undergraduates, right? Because I don't really have much interaction on undergraduate programs. But at the postgraduate level, we work with universities, as I said, to do some of these research programs, right? And a lot of it's done by their students, right? So I think if there is collaboration between universities and the industry, then there's opportunities for students to be exposed to the industrial needs, right? And they quickly figure out what they need to do, what they need to learn and how to improve their skill sets and so on and so forth. And they develop the right skills to be employable. For example, there was a foreign student actually partly developed that platform of that arm that moves, right? So I think he was from Iraq, if I'm not mistaken. So this guy finished his master's or whatever, then immediately got snapped up to do for a position in Germany, right? Because of all the talent, all the skill sets that he developed through working in UPM, right? On this project. So yes, for postgraduates, yes, I think so.
Thank you, Dr. Harikrishna. Once again, thank you, Dr. Harikrishna, for all the answers. Dear participants, for those unanswered questions, don't worry, we will get the answers from our speaker later, and the answers will be posted on our social media. So do follow us at our CEUC on Facebook and Instagram by clicking the links provided in the chat box to get the latest updates. Before we move on, Dr. Harikrishna, do you have anything to add on?
Yeah, I was requested by the organizers to actually share some thoughts with regards to what you guys need to do moving forward. So the world that you're inheriting or you're coming into is what they call a VUCA world, right? So it is volatile and so on and so forth, uncertain, and therefore you have to be very adaptable. You have to be multi-skilled. I think that's very important, because none of us can actually look at a crystal ball today and say, these are the skill sets that are going to be important for the next 10 years or beyond 10 years, right? Because technology changes so fast and the global requirement also changes so fast, right? So I think basically being adaptable being resilient, learning how to be resilient, being multi-skilled, and essentially having a curiosity to learn, right? I think that should put you in good state to actually do well post your graduation.
All right. Once again, thank you, Dr. Harikrishna. It is truly our honor to have you with us today, and I believe each and every one of us benefited from your sharing just now. Now, before we end this session, I would like to ask everyone to switch on your cameras for a photography session together with our speaker.
Okay, everyone, please get ready. We'll wait for a few minutes while everyone is switching on your cameras. Okay, so I believe most of you guys are ready with your cameras. So on my count of 3, 1, 2, 3, smile. And another one, 1, 2, 3, smile. Okay, I'll move on to the second page now. 1, 2, 3, smile. The third page, 1, 2, 3, smile. And the final page, 1, 2, 3, smile. Thank you.
Thank you for your cooperation. And with this, our third session has come to an end. Now, we will have a short break before we continue with our next session, which is the prototype demonstration competition. Let us take a break and we shall meet each other again at 11:15 a.m. later. Thank you.
Okay, thanks. See you guys.